When trying to determine the greatest common factor of any two numbers, you first need to factor each number itself. You can go about this by making a list or a factor tree. The easiest way for me is to make a list. By making a list, just simply write out each factor next to the number you are factoring. For example, if you are factoring the numbers 4 and 12, you would first write a 12, a semicolon, and then list their factors. The first factor of 12 is 1 and 12. So in parentheses, you would write 1 and 12, comma 12. The next is 2 and 6, 2, comma 6. The next factor is 3 and 4, 3, comma 4. Those are all the factors of 12. The next number we're trying to factor is 24. And we're trying to get the greatest common factor of 12 and 24. So you would put 24, semicolon, and then you would write its factors. The first being 1, comma 24. The next, 2, comma 12. The third being 3, comma 8. And finally the fourth would be 4, comma 6. And it would look like this. From this, you can tell that 12 is the greatest common factor in both of the two numbers. So, therefore, you would circle the 12 in each list, like this, deciphering that it is the GFC of those two numbers. In this section, we will be doing special products. The section includes factoring the difference of square binomials and factoring perfect square trinomials. In factoring the difference of square binomials, you will have two perfect squares being subtracted from each other. Then, you would need to find the square root of each of those two numbers. If r squared minus 4 was to be factored, what would happen? Let's take a look. If r squared minus 4 was factored, what would be the first step you need to do? Well, first, you need to find the square root of r squared and the square root of 4. The square root of r squared is r. The square root of 4 is 2. So, from this, we can put r minus 2 in parentheses and r plus 2 in parentheses, like this. In checking this problem, you would need to do the FOIL method. In the FOIL method, you would first multiply r times r. That would leave you with r squared. Next, you would need to multiply r times 2. This would leave you with 2r. Then, you would need to multiply negative 2 times r, leaving you with negative 2r. And finally, you need to multiply negative 2 times positive 2, leaving you with negative 4. When you add these all together, you would get r squared plus 0r minus 4. This bottom answer is the exact same as the top answer, so therefore you know it's the correct answer. The final answer after factoring r squared minus 4 would be parentheses r minus 2 parentheses r plus 2, meaning that you would multiply the two factors. The next area of the special product category is called perfect square trinomials. The first thing you would need to do is to actually find out if your problem is a perfect square trinomial. In order to find this out, the first and the third term need to be perfect squares. If the first and third terms are perfect squares, Then when you find the square root of those two numbers and they are added together, then when you multiply them by 2, you should come up with the second term. This is how you know if you have a perfect square trinomial. Once you've figured that out, you can go about factoring the perfect square trinomial. T squared plus 12t plus 36. How would this be factored? Well, first, you would need to find the square root of t squared. The square root of t squared is simply t. So in parentheses, the first factor would be t. The next thing you need to do is find the square root of the last term, 36. The square root of 36 is simply 6. Since the middle term, 12t, is positive, you would add both t plus 6 and t plus 6. It would look like this. To go about checking this problem, you would need to do the FOIL method. T times t is t squared. T times 6 is 6t. 6 times t is 6t. And finally, 6 times 6 is 36. When you add all of those together, you get t squared plus 12t plus 36. It would look like this. Since the bottom answer summed up to be exactly like the top answer, you know that t plus 6 and t plus 6 are the two factors of this perfect square trinomial. The next section is called factoring trinomials. This is different than factoring perfect square trinomials because in these trinomials there's only one perfect square. The first thing you need to do is find the greatest common factor. The second thing you need to do is to determine the binomial factors. The third thing, you would need to check your work using the FOIL method. For example, 3x squared minus 24x minus 60 was to be factored, what would you come up with? The smallest term in this trinomial is 3. So if 60 and 24 are divisible by 3, then 3 will be the greatest common factor. 24 divided by 3 happens to be 8, while 60 divided by 3 happens to be 20. So therefore you know that 3 is the greatest common factor. You would put 3 outside of the parentheses and then begin to factor your problem. From here, you would have 3 parentheses x squared minus 8x minus 20 parentheses. It would look like this. From this point, you need to factor out the rest of the problem. The 3 would stay outside of the parentheses. Then, since x squared is the first term, you know that x is the first factor in each of the parentheses. This third part is a little bit trickier than the last. From here, this is what our problem would look like. As you can tell, we have yet to find the second factor. I'm going to erase the board so we can go about finding the second factor. In order to determine the second factor of the problem, you would need to have two numbers that multiply to equal negative 20 while they add to equal negative 8. So the first thing you would go about doing is finding the factors of negative 20. The first factor of negative 20 is negative 1, 20. The second, 1, negative 20. The third, negative 2, 10. The fourth, 2, negative 10. From this point, we don't need to go any farther. We know that we are looking for two numbers that multiply to equal -20 and add to equal -8. We have already found these two numbers. When added, -10 and 2 equal -8. So, therefore, 2 and -10 are multiplied to equal -20, while -10 and 2 are added to equal -8. These are the two numbers we will be using in the answer. From everything previously stated, we now know the correct answer. 3 is outside of the parentheses, while inside of the parentheses the factors are x minus 10 parentheses and x plus 2. We know that this is the correct answer because of the FOIL method. When these two factors are FOILed, we come up with x squared plus 2x minus 10x minus 20. Therefore, the final answer is x squared minus 8x minus 20, and it looks like this. That is how you factor a trinomial. In the next section, we will be talking about factoring by grouping. There are two different sets of problems that we will be going over. In the first set, we will be factoring polynomials with 4 terms. In the second set, we will be factoring trinomials by grouping. Factoring polynomials with 4 terms, you first need to find the greatest common factor, if one exists. The next step is to group these terms. The third step, factor the greatest common factor from each group. The fourth step, factor the common binomial. We will go over these in an example. The problem will be 30c to the third power minus 20c squared minus 15c plus 10. It will look like this. The first thing you will need to do in this problem is try to find a greatest common factor. In each term, the variables are divisible by 5. Therefore, 5 will be the greatest common factor. You will put that outside of the parentheses, and then state the factors. When factoring the 5 out, we now have 5 parentheses 6c3 minus 4c squared minus 3c plus 2 parentheses. It will look like this. From this point, we are going to group the terms. Since none of these terms actually go together, we are going to group them into 2 different sets. The 5 will stay on the outside, but we will group the 6c to the third power minus 4c to the second power into one group, while -3c plus 2 will be into another group. From this point, you will need to factor the greatest common factor of each of these groups. That's the problem this far so that we can focus on each group individually. 6c to the third power minus 4c to the second power is the first group, and it looks like this. From this point, you will need to factor out the c. The greatest common factor in this case will be 2c squared. You will factor this out and come up with 2c squared in parentheses 3c minus 2, and it will look like this. As for the second group, -3c plus 2, you will need to find the greatest common factor in this binomial as well. It will look like this. From this point, you will need to find the greatest common factor of this binomial as well. The greatest common factor happens to be -1. Negative 1 is on the outside, while in parentheses, negative 3c plus 2 will change into 3c minus 2. That is the factor of the second group, and it will look like this. From this point, we will combine all of the factors in both groups together. This leaves us with 5, a bracket, 2c squared, parentheses, 3c minus 2, parentheses, this is the second group, minus 1, parentheses, 3c minus 2, parentheses, bracket. And it will look like this. This leaves us with 5 on the outside, and in parentheses, 3c minus 2, also in parentheses, 2c squared minus 1. This is the final answer, and it will look like this. You need to check your work using the FOIL method. When you FOIL out the two factors, first you will need to multiply 3c times 2c squared. This leaves you with 6c squared. The next, 3c multiplied by negative 1. This leaves you with negative 3c. Next, negative 2 multiplied by 2c squared. This leaves you with negative 4c squared. Finally, negative 2 multiplied by negative 1. This leaves you with positive 2. It will look like this. From this point, you will need to distribute the 5 in front of the polynomial. This leaves you with 5 times 6c squared, which is 30c squared, minus 5 times 3 minus 5 times negative 3c, leaving you with negative 15c. Next, you will need to multiply 5 times negative 4c squared. This leaves you with negative 20c squared. And finally, you will need to multiply 5 times 2, leaving you with 2. It looks like this. After foiling this problem, we can tell that this is the correct answer because it matches up with the original problem given. The last segment I'm going to go over is called the sum and difference of cubes. There are two formulas in which you need to know. I will write them down. Cubed plus b cubed equals a plus b in parentheses multiplied by a squared minus ab plus b squared. It looks like this. The next formula you're going to need to know is called the difference of cubes. And it is a cubed minus b cubed equals a minus b multiplied by a squared plus ab plus b squared. And it looks like this. The only difference in these two formulas is that one is being added while the other is being subtracted. From this, we will try a problem. T cubed minus 27 was to be factored. What would you come up with? Well, first of all, this would be the difference of cubes pattern. T cubed minus 27 is subtracting t cubed from 27. So we first need to find the cube root of t and 20. The cube root of t to the third is simply t. The cube root of negative 27 is negative 3. From here, you would multiply t minus 3 by t squared plus 3t plus 9. And it looks like this. The reason I figured all of this out is because I simply followed the pattern given to you beforehand. Next, I will be showing you how to figure out the sum of cube roots. Example, if 2z cubed was being added to 250, what would be its factor? Well, first of all, you would need to divide this binomial by 2. When dividing this by 2, you would get z cubed plus 125. From here, you would need to find the cube root of z cubed and 125. The cubed root of z cubed is simply z. The cubed root of 125 is 5. So, therefore, it is z plus 5 multiplied by z squared minus 5z plus 25. That is the final answer. And here's what it looks like. I figured this problem out from the formula previously given at the beginning of this section. And that is the end of all of the sections. I hope you learned something new.